Hello, my name is Sam. I'm an online maths tutor for GCSE and A-level maths, and this is a video all about the product rule with differentiation. So let's get straight into it. So my last video was on normal differentiation for simple terms, and so this time we're going to look at the product rule. There will be some harder derivatives in this, such as things to the power of x and lunds as well, and so we're going to have a look at some of those. I won't be teaching how to do those, but if you don't know them, then you could pick them up from this video. So let's get straight into it. We have a curve y equals 3 plus x squared times by 4x minus 1, and we want to find its derivative. So let's start with dy by dx. And now there is two ways of doing this question. You can expand this expression and differentiate it all in one, or you can use the product rule. And whichever one you find easiest doesn't really matter, because we're going to look at the product rule in this video. So the product rule is used specifically for when you have two x terms which are multiplied together, or just two terms multiplied together, and you want to find their derivative. You can do that by, well, I'll just show you the equation. So for any equation, y equals u times by v, the derivative of y by dx, so we're going to imagine u and v are some functions of x, is going to equal u dv dx plus v du dx. Now this basically means it is the u term multiplied by the differential of the v term plus the v term multiplied by the differential of the u term, all of which is with respect to x. And this will find your derivative for your whole function. And so we're going to apply that in this case. So we're going to start with finding out what our u and our v terms actually are. So it doesn't matter which way round these are, since they're both multiplied together. So our u is going to be our 3 plus x squared, and our v is going to be our 4x minus 1. We're then going to find our differential of our u term, so du by dx. So 3 plus x squared differentiated is going to be 2x. The constant term disappears, and then we bring the power down and drop it by 1 to just get 2x. And the differential of our v term, dv dx, is going to be, well, this x is going to disappear, and our constant term is going to disappear, so this is just going to be 4. If you're confused about where I got those numbers from, please do check my previous video. So let's fill in this equation on the left-hand side. Dy dx is equal to u, which is 3 plus x squared, times by dv dx, which is 4. I'm going to need to rub some of this stuff out. Actually, I will move it. Hello. There we go. Down there. And this is going to be plus our 4x minus 1, which is our v term, multiplied by the differential of our u term, which is 2x. We can then expand this expression. So 3 times 4 is 12, plus 4x squared, plus the 4x times the 2x is 8x squared minus 2x. If we collect these terms, we get 12x squared minus 2x plus 12 is dy by dx. Fantastic. And this will be our gradient function, or our gradient machine, or our derivative machine, or whatever you want to call it, for this expression with which we started with. So it's not too complicated of a process. You just need to remember that it's u dv dx plus v du dx, and you just need to make sure you get your u, v terms right and you differentiate them correctly. So let's move on to our next example. Here we have 4 to the x times by 2x cubed. So this one looks a little bit trickier. Unfortunately, there is no way to expand this and simplify it so that you can differentiate it normally. This has to be done via the product rule, which is just fantastic, isn't it? So let's start with writing down our y equals 4 to the x times by 2x cubed. Now again, we're going to pull up our equation, so dy by dx is going to be equal to u dv dx plus v du dx, and then we're going to write down what our u's and our v's are. You must do this in an exam. It is very important to write down your u's and your v's. If you use a substitution and you haven't made it clear what you're substituting and why you're doing it, the examiner may dock you marks if they're feeling harsh, or if it is a picky mark scheme. So please, please, please write down the u's and the v's and the du's and the dv's dx's. Yes, so our u term is just going to be one of these. It doesn't matter which, 4 to the x or 2x cubed. So we will go with 4 to the x for our u, and our v is going to be 2x cubed. Now we need to differentiate both of these terms. So I've written u dash here, which does mean the derivative, although I'm going to replace this with du dx and dv dx. But equally, you could write u dash or v dash. They both mean the same thing. So our du dx term is a differential of our u term, 4 to the x. I'll come back to this. So we're going to differentiate our v term. 3 times by 2 is 6x, and then you do the 3 minus 1 is going to be 2. So this is 6x squared. And now we need to differentiate 4 to the x. If you haven't seen this before, it's something that you are going to need to just remember, unfortunately. But yes, 4 to the x differentiated, or well, should I say a to the x. I'm just going to say that a is any constant. If I am going to differentiate this, I'm going to write down the operator d by dx. This is to differentiate with respect to x. Is going to equal a to the x ln a. Okay, so in this case, it is going to be 4 to the x ln 4. Okay, fantastic. So now that we know our u, v, du, dx and dv dx values, we can substitute those into our equation. So over on the left here, dy by dx is going to be equal to u dv dx, so u is 4 to the x dv dx, which is 6x squared, plus v, which is 2x cubed, du dx, which is 4x, 4 to the x ln 4. We can then write this out in a nicer way. So we have 4 to the x times by 6x squared. Unfortunately, there actually isn't a better way of writing this. So we're just going to leave it like that. Plus 2x cubed times by 4 to the x ln 4. Again, there is no nice way of writing this. We're going to have to leave it as 2x cubed times by 4 to the x ln 4. So quite a horrible question, that one, only mainly because of the 4 to the x term, which is kind of skewed up by simplifying. But yes, you need to make sure you remember those derivatives. You won't be given them in the exam. You need to remember those. Yes, if you're then asked for the gradient of this at any point, any x coordinates, you must then plug it into this expression down here, and you will get your dy by dx, which will be your derivative. Lovely. Let's take a look at our final example. So y equals 6x times by ln x. This one's going to be a little easier than the previous one if you know the derivative of ln x. So dy by dx, we're going to write down what our equation is again. So dy by dx is equal to u dv dx plus v du dx. So what is our u, what is our v, what is our du dx, what is our dv dx? Let's find out. So u, we're going to say is 6x, and v is going to be ln x. Now the differential of 6x, so du dx, is going to be just 6, as we just remove the x term. And the differential of our ln, so dv dx, is 1 over x. If you did not know that, I've got that from differentiating what is inside of the ln term and simply placing it on top of the fraction and putting x on the bottom. This is not some weird derivative fraction, this is just a normal fraction. You could write it as x to the power of minus 1, but yeah, that is the derivative of ln of x. So substituting these values into our equation, we get 6x, so this is u, times by dv dx, which is 1 over x, plus v, which is ln x, times by du dx, which is 6. So this simplifies to 6 plus 6 ln x. So your gradient at any point on this function is going to be 6 plus 6 ln x. Quite a nice solution, that. Yes, also note the ln x here. Make sure that if you're asked to find a gradient, you absolutely read the question and check that it does not want an exact answer, in which case you will have to leave the ln in your answer. Also, there is a derivative button on your calculator, but I would recommend almost never ever to use it, as it is an approximation and it will not give you the exact value. Even if you look at the decimal and you subtract it from your actual calculated value and you have the correct value, you may not be correct. So yes, I hope this video was helpful with a good summary of the product rule. If you like what you saw, please do subscribe to see more, and thank you for watching.